Hello, I'm Trisha. I'm going to talk to you about tests and automated tests. And I pose the question, are your tests slowing you down? Right. So, as an introduction, please buy my book, basically. That's all I'm here to say. I will be giving away a free copy of Getting to Know IntelliJ IDEA, but you have to wait till the end of the talk to get the QR code for that. So, that's your tough luck. But what do all these books have in common? Oh, I should have introduced myself properly, really. I'm Trisha. I work for Gradle. I used to work for JetBrains, did a lot of stuff with IntelliJ IDEA, and did a lot of stuff around talking about Java, new versions of Java, and things like that. And so the books that I contributed to, 97 Things Every Java Programmer Should Know, Head First Java, and Getting to Know IntelliJ IDEA, are all about trying to get developers up to speed on the tools they use all the time. And I realized the thing that they have in common is about developer productivity and what it is that helps us to be more productive and hopefully have a bit more fun in our jobs. I say fun because if you know what you're doing, I think it feels more comfortable to do the jobs. So that's why I moved to Gradle, because Gradle's doing a lot more talking around developer productivity and what it means to be productive and how we can speed up some of the chores and tasks that we do. So Gradle's talking about something called developer productivity engineering, which is what I talked at DevBcn last year about. And it's all about how to use tools and engineering practices to improve our productivity as developers. A software development practice to maximize developer productivity, but more importantly, the happiness part of developers, I think. You tell your bosses it's all about productivity, and for yourselves, it's all about your happiness. So, tests make you more productive, right? I think when I have this conversation with a bunch of developers, they tend to fall into two kinds of camps. One is, I love tests, they make me feel good, they tell me that my code is doing the right thing, and the other camp is, oh, testing. It's so painful, and it's just so slow, and it totally gets in the way of what I'm trying to do. And sometimes a developer is in both of those camps. It's possible to feel both of those things at the same time. So yes, so this is how we feel sometimes when we're writing our tests or running our tests. And it's not really what we talk about when we talk about developer joy and productivity. It's more of a head desk moment. There are a bunch of GIFs in this. There's fewer than there were the last time I gave this, because I kind of stuffed it full of Disney references, because my kids watch a lot of Disney, and that's how I write my talks these days. So I'm here to tell you that it's OK not to write tests, right? No, please do not walk out of this room saying, Trisha says it's OK not to write tests. That is not the point of this presentation. What I really want to talk about is how to make us more productive while we're writing, running, and using automated tests. I don't have my next slide available, so I'm just going to have to try and pretend I know what's happening on the next slide. Right, so testing is a good thing. I'm a big fan of testing. Kent Beck said, testing is Xanax for programmers. It's an anxiety-reducing technique, which is how I feel about tests. When I first started out on my career, I worked with a bunch of professional testers, and it was nice to have them there, because what they do is tell you your code works. Well, often what they do is they tell you your code doesn't work, and you have to go back and fix it. But it's nice to know that there's some sort of testing thing between you and the users to make sure that your code works properly. And automated tests are a good way of doing that, too. It gives us security that we have done the right thing, probably. So I usually have a bunch of caveats in my talks, and the caveats for this talk are, I have got a bunch of GIFs. 5-year-olds do fall asleep in this talk, and there will be a certain amount. I have tested it on a 5-year-old. And this program does contain product placement. So I work for Gradle. What a lot of people don't know is that Gradle has two products. Gradle Build Tool. Who's using Gradle Build Tool? OK, who's using Maven? OK, that's about right, 50-50. That's kind of normal. And I'm not going to talk about Gradle Build Tool. I'm going to talk about our other product, DevVelocity, which is a developer productivity tool. But you know how developer advocacy works, like 90% thought leadership and occasional product placement. So when I'm talking about the product, I will have the DevVelocity logo, so feel free to fall asleep when I'm talking about the product. However, if it is interesting, please do call our salespeople. They will be very happy. And the other caveat is that a lot of the stuff I'm going to talk about is not groundbreaking and new. It's all stuff that we already know. But it's things that we can remind ourselves when we're struggling in terms of writing, running automated tests. So there's nothing groundbreaking. And that's a good thing, really, because it means that the stuff that we already know about testing is good and solid, and it works. So I did a Twitter poll, because I write my tests using social media, and I'm not going to call it X, because it is not called X. I wrote a Twitter poll and asked, what slows you down when it comes to testing? And the answers were, for a bunch of people, writing tests slows us down. And then running tests locally, running them in CI, that doesn't slow you down as much as I thought it would. I thought that running tests is one of these things that slows us down, because we have to wait a long time for the results of our tests. Debugging and fixing tests, also not as impactful as I expected. What was really interesting is unreliable test results slows us down. Because if we've spent all this time writing tests, and then we can't rely on the results, did it really pass? Did it actually fail? Or it failed, but it didn't really fail? That is a blocker to our productivity, because we can't trust the results of our tests. So what I want to do with this presentation is split it into 3 parts. I'm going to talk about techniques for accelerating writing tests, techniques for running tests faster, even though that's only a small amount, how we can help debug our tests, and I will talk a little bit about flaky tests. So writing tests takes time. I do want to caveat this bit as well. When I was speaking to Liz Keogh, another speaker when we were in Australia, I was talking to her about automated tests, and she said that I'm actually a tester, which I thought was very weird because I'm a developer, not a tester. But she said that the way that I think about testing is often the way that testers think about testing. So when I talk about testing, I don't always come at it from the point of view of a classic developer, because I quite like that viewpoint of, oh, let's see if we can write some more tests. So some of this stuff may or may not resonate with you if you're not really a testing kind of person. Obviously, we're going to do a demo with the IDE, because I have a book to sell, and that's what we do. So let's talk about how to use our IDE to speed up writing tests. We will be using IntelliJ IDEA. Who's not using IntelliJ IDEA? OK, that was very brave. Well done. We are going to, right, let's, you can't see that at all. Let's get this to Zoom. OK, so if we have a test, if we have a class like the user service, we can get IntelliJ IDEA to create a new test for this class. I personally like to create tests first, but let's assume that you've written the production code first. I'm going to create a test, add it to Git. We can get IntelliJ IDEA to generate a test method, and it will do the absolute basics to get a test method that compiles. I personally have a live template which creates a test that I like. So I've created this live template, which will create a JUnit 5 test with placeholders for given, when, and then, and sets up the name of the method the way that I like it. So I'll say something like, should get the correct username out of a tweet. OK, I'm going to use some keyboard shortcuts to paste in some test data. And then I'm going to use one of my favorite things, actually, underrated thing, where you can put this inside. Hold on a second. Get the right shortcut. Inside an editor fold. I'm going to call this example input. I'm going to spell that incorrectly. And then you can just fold away lines of code. So if you've got stuff which is kind of getting in your way of reading your code, you can collapse that with an editor fold, which is quite nice, because that was quite nasty and in our way. So now we're going to say user service dot. I don't actually have. I want this method. I'm going to use copy and paste, which I don't usually like, but that's the right thing to use here. Put in the example input. Going to use F2 to go to the error. Going to use IntelliJ to fix the error. So the error is, this is a private method. I'm going to make it package private for testing. Let's not have the argument about testing private methods right now, because that's like way beyond the scope of this presentation. So then let's get the handle out, and I want to assert equals Trisha _Gee, and then I've got full line code completion in the latest version of IntelliJ IDEA. And that's not Copilot or IntelliJ. Well, it is AI, but it's not phoning home AI. It's just local AI, which will generate what it thinks is the right lot of code for here. So let's run this. Well, let's get rid of this as well. Don't need this. Let's run it. Every time I give this demo, IntelliJ IDEA has more ways of helping me to write this code. OK, so it passes, which actually makes me a bit dubious because I really like to see my tests fail. So let's see if it fails for the right reason. Come up here. OK, good. So it fails for the right reason. And right. So this is classic, IDE 101 stuff. Use code completion, code generation, full-line code completion, keyboard shortcuts, and so on to help speed up while you're writing tests. Obviously, it's a little bit of a cheat, because I already knew what this test was supposed to look like, so it doesn't take me as long to write it. But the point here is that if you know your IDE, you can lean on the IDE to do a whole bunch of the boring stuff in terms of writing the code. So then you don't have to think so much about how do I write an assert. You just get IntelliJ IDEA to do that. And using things like live templates to give you the shape of the methods that you want them, that is also really helpful for just getting rid of the cognitive load of all the boilerplate and focusing on what is this test? What should it do? What am I expecting? So you can use tools to do that. OK, so use your IDE. By the way, I do have a course on this, so if you do feel like buying the course, that would be marvelous. I talk a little bit about how to use IntelliJ IDEA to do TDD. At the end of the presentation, I will have a QR code with a link to a page with all the links for all this stuff in if you are interested. Now, it's 2024, I think, and everyone's talking about AI. So of course, we're going to use AI to write our tests. Because if I didn't put AI in this presentation, no conference will accept this presentation. You have to have AI, or it doesn't work. That's how it works these days. So I'm going to use JetBrains' AI assistant because, well, because JetBrains gave it to me for free, but actually, because I really like it, it integrates very nicely with IntelliJ IDEA and helps me in the way that I normally work with code. Previously, I was using Copilot, which also worked quite well, but the integration between JetBrains' AI assistant and IntelliJ IDEA obviously is very good because it's designed to work that way. So let's have a look for a class, mood service. And I'm going to, what can we see? I want to write a test for this method. Let me have a look for the mood service test. So this tests one of the methods, but it doesn't test the other one. So I'm going to get AI Assistant to generate unit tests, which it's going to think about. So I am somewhat skeptical. Well, I'm skeptical about writing tests after the fact anyway. I do think we should be thinking about what the code should do in advance rather than testing what the code does do. But let's assume that, and the reality of the situation is we have a bunch of code which is not currently tested. So if we can use tools to help write tests for our untested code, then that's a good thing. So it's generated a JUnit 5 test for me. Has it generated? Oh, it's added it to the existing test. That's nice. The really fascinating thing about using AI is that it just does something different every single time. So this morning, I tested this presentation, and it created a brand new file with brand new tests in. And this time, it's gone, oh, you already have a test for that. Let's just add it into that. This is one of the things I don't like about AI. The lack of predictability around it is somewhat, to me, it's the opposite of code generation in your IDE. Code generation in the IDE is predictable. By definition, it's always the same stuff which comes out. AI just goes, well, today we're going to do it this way. Tomorrow we'll do something different because I got bored. OK, so it's created a bunch of methods. Should correctly map message to CSV. I hate that method name, but that's something that I would probably go and change. Should correctly map given messages to CSV format of moods. OK. Should handle empty messages gracefully. Oh, that's nice. What else? Should handle messages with no moods. I do like the fact that it's actually it's created this so that it looks very similar to my existing tests, which is quite nice. And then, of course, so here's the thing about AI-generated stuff. Even if I run this and it works, I really do need to read the code and find out if it does what I think it's doing. And in my mind, maybe I'm wrong, but in my mind, reading code that someone else has written is far more difficult than me just writing the code to begin with. So there's a certain, to me, there's a certain slowing down of reading AI-generated tests because I have to understand, I should understand what the test does, and if it's correct or not, and if it follows what I want. So this kind of seems fine. And then I can do things like, can you please add a test for an unhappy message. And then it should go away and do that, maybe. Sometimes it works, and sometimes it doesn't. It's thinking. Well, it hasn't put a space in the right place. Unhappy messages. OK, that's kind of fine. Oh, and the other thing I wanted to do is I want to do something like, can you please use parameterized tests? Which sometimes works. And honestly, I really do think it would be faster for me to write these tests myself. But we have to learn to work with new technologies when they come along. And obviously, with the AI models as well, as it learns from you, it's the results that it creates are closer to what you want them to be. So I usually try and clean this down to be sort of a fairly untrained model, because it's easier for demos. But that's not necessarily how you'd use it in the real world. So that's quite cool. That kind of works. So let's accept that. It kind of works. I don't know. Let's see if it compiles. Oops, that's not what I wanted to do. Oh, look, a compilation error. Yes. And then you spend like 2 days doing code review on AI-generated code. Great. I actually quite like the fact that this doesn't work, because I'm a bit cynical about AI solutions. I don't even know what it's done. So great, you should definitely use AI. That's definitely going to make things easier when you're writing tests. I think that proves my point. OK, mandatory AI demo out of the way. So AI is going to make you super productive for this sort of thing, potentially, maybe, if you can get it to do what you want, and if today is Wednesday, and it's a full moon, and it's decided to write the test the way you want them to. So I asked Twitter, again, and actually asked Mastodon, do you use AI to help write the tests? And generally, a lot of people are using AI to help generate tests. There's a bunch of caveats, though. Yes, it's fine most of the time. It's a good tool, especially for legacy code. It can help you reason about the code that's been written, and it can do the heavy lifting of creating a whole bunch of boilerplate. But you do still have to read it. You do still have to understand it. And it's not, it comes with caveats. Also, AI just hallucinates. It just talks a lot of crap half the time. So I asked it for some quotes for this presentation, and it said Agatha Christie said, "There's nothing new under the moon," or something. And I was like, "Oh, when did Agatha Christie say that?" And it was like, "Oh no, she never said that. I just made that up." Like, okay. So you do have to be very wary of the results that come from an LLM, for example. And my old boss, Dave Farley, one of the things that he always said, especially when we were talking about pair programming, is it's not the keyboard that's the bottleneck. It's not the writing of the code, the typing of the code, which slows you down. So things like AI and code generation and things, they can help us to some extent. But it's not the generation of the code that takes the time. It's the reasoning about it. It's the thinking about it. What should it do? Is it really behaving the way I expect it to? Did I go down a rabbit hole and implement what was in my head without looking at the specifications or the card or the whatever? And did I not really think about how the end user was going to use it? So when we're writing our tests, the thing that takes the time is the thinking, not the typing. So there's only so far that certain tools will take you. I quite like AI in terms of helping prompt some of those thoughts. It helps us think, oh, right, I didn't really think of that. Is that really something we should worry about? And so the process of creating tests is not about typing code into your IDE. It's about reasoning about what the code should do. Another way to help speed up writing tests is to bring a friend. So the last quote was about, Dave Farley was talking about pair programming. We used to do a bunch of pair programming together. And the keyboard is not the bottleneck, because you spend a lot of time talking to the other person and coming to a better solution between the two of you. So having two people at the keyboard can sometimes help speed you up, because you don't get stuck in that bottleneck of like, oh, what am I doing? Should it do that? Am I doing the right thing? And you can kind of break out of those cycles if you've got someone to talk to. Particularly when it comes to testing, it's a really good idea to pair with someone a little bit different to you when you're trying to create tests. So in this book, Lisa Crispin and Janet Gregory said, we recommend that the developers who are good at writing efficient, maintainable code work together with the testers who are good at specifying test cases to automate the tests. This is something I used to do when I worked at LMAX. We would write the automated acceptance tests with one of the QA people. So one of the developers would sit with one of the QA folks, and we would come up with the scenarios together, because the QA folks were really good at saying, what about this? Have you thought about that? What are we going to do when this happens? And the developer would be like, oh, that's kind of interesting. I can solve that problem. And we would write the tests together. I recently finished reading Organizational Physics, and this talks about 4 personality types. It talks about stabilizer, producer, unifier, and innovator. And it's not necessarily that one person is always just one of those things. It's that one person tends towards some balance of these things, and as that person moves into different roles or different circumstances, the focus might slightly change. But it's quite a good way of thinking about the strengths and weaknesses of a particular individual or team when you think about, are there people who can do these things? When it comes to testing, I think that you need people who are strongly able to think as stabilizers. In fact, it specifically says here, quality control. So stabilizers have a structured approach, a slower pace, organizer, quality control. So you need to be in that headspace of stabilizer when you're thinking about testing. I think a lot of developers tend to be in the producer-innovator space. So we're talking about working hard, like working fast, being creative, moving forward. And so when we're writing automated tests, we need a bit of all of those things. We need the stabilizing influence and the producing influence. And it's kind of the tension between those things which should help create good code with good automated tests. But I think it also explains why some people struggle with the writing the automated tests, because their headspace is not necessarily in the stabilizer mode. And I think it also explains why people who are natural stabilizers can sometimes struggle communicating with people who are innovators and producers, because the stabler wants to slow these people down and make everything a bit more structured. Working together in those spaces, I think, is where we get some really effective tests and production code together. Now, there's a quote from an American poet which says, "Creativity is a wild mind and a disciplined eye." And I think this is really key for creating good quality applications. You need the wild mind for the innovation and the producing and the creativity, but you need the disciplined eye to make sure it does what it's supposed to do, it doesn't fall over, it doesn't annoy the users, it doesn't lose money, it doesn't, go and steal money from banks or whatever, I don't know. You need both of those things. You need the creativity and the stabilizing force. And that's why it's so important to have good automated tests when you're writing production code. The last thought I want to leave you with when it comes to writing tests is it's worth investing the time in writing the tests, because that will save you time during troubleshooting. And as we probably know, although my Twitter poll says writing tests slows us down, I do think troubleshooting is probably something which is even more frustrating than writing them. Because when something fails, we don't know what went wrong, especially if the tests are badly written. So let's talk a bit about troubleshooting taking time. The first sort of anti-pattern that drives me crazy when I have to troubleshoot a failed test is when I don't understand what that test should have been in the first place anyway. My particular pet peeves with anti-patterns are dreadful test names and using assert true or assert false. Because when a test like this, test increment, returns false, I'm like, okay, but what was I testing? Am I testing it's supposed to increment, or it's not supposed to increment, or it increments by this much, or it doesn't increment under certain circumstances? And then when I expected true and I actually got false, like, what was false? Why did I think it was going to be true? So when it comes to troubleshooting this test, there's very little information here to help figure out what on earth went wrong. Was it the test? Was it the code? What happened? So my preference is to err on the side of a more wordy test method name, particularly with JUnit 5 using the display name, so you can put spaces in and make it more descriptive, and you can use special characters and so forth. And also to use something like, I prefer things like assert equals and things, so you can actually see the comparison between what we got and what we thought we were going to get. Like, even if what we thought we were going to get is true, like, assert the list is empty. If you're going to use something like assert true, which I hate, at least put a message in the assert true, so you can say what you thought was going to be true and what wasn't true. So descriptive method names are really helpful for the troubleshooting. So write better tests so it's easier to troubleshoot them. Ideally, although it's difficult, ideally your test needs to tell you if it's a problem with a test or a problem with a production code when it fails. So when something fails, when the assertion fails, you want to get some sort of clues from the method name and from the assertion failure of like, oh, does that feel like the requirements changed so the test is no longer valid? Or does that feel like the database went away from underneath me so the test failed because the code doesn't work properly? So you want to be thinking when you're creating these things, like you want to be thinking, when this inevitably fails, because the whole point about tests is at some point they will fail. When it fails, what is it going to tell me? Is it going to help me figure out what went wrong? And I want to show you a couple of tools for seeing more when you are troubleshooting tests. For example, inside IntelliJ IDEA, we have, let's look for a stack trace. Hold on. Let's say that you get a stack trace in CI or production. Let's see what we've got here, scratches. One of these somewhere, there we go. If we've got a stack trace and we copy it from some log file somewhere, you can use analyze stack trace or thread dump, and I can put it in here. I copied that. Copy, analyze stack trace. And then you paste your stack trace in here, you say OK, what it will do is it will open up into a navigable stack trace, and then I can click through to these individual places, I can drill into those things. I mean, obviously the caveat with this is the code in your IDE needs to match up with the code through the exception, otherwise your line numbers are all going to be off. But it's a really helpful way of navigating through things like exceptions. The other tool, which is a bit of a plug for Gradle, is Gradle has build scans. So if something goes wrong with your tests or with your build, you can publish a build scan. This is a free tool. You can publish the build scan, and the build scan has loads of information about the environment that those tests were run in. So it shows things like the operating system, the number of CPU cores, the version of Java, but it also has things like it looks at all the dependencies, so you can see which dependencies were used. It will show you asked for these dependency versions, but it actually used these dependency versions. So it's quite a good way of troubleshooting the environment under which your test ran, particularly if you run it with a build tool. So this works for Maven, Gradle, SBT, and if you're paying for Develocity, it works for Bazel as well. So it's quite a good tool for troubleshooting particularly CI builds, but also helpful for local builds when you're trying to figure out, like, did it do what I thought it was doing? Is it using the dependencies I thought it was using? Is it spinning things up the way I expected them to? The key for troubleshooting tests is to aim for fast feedback and easy reproduction, because not only do you want to be able to reproduce the problem, but you also want to poke at it and reproduce it multiple times to see if you can fix it, right? So if it's a test that takes 35 minutes to run, you're like, well, I think I might just delete the test because I'm never going to be able to troubleshoot that, because every time I run it, I'm going to have to go off and have lunch like 15 times a day. So you're really looking for fast feedback and easy reproduction to help troubleshoot your tests. Gradle has a big push about build local, because obviously if you're running it locally, you've got way more tools at your disposal. You can use your IDE to dig in. You can poke around at log files and things like that. So if the tests fail on CI, it's more difficult for you to troubleshoot what's going on with them. So we have a number of tools to try and help make things easier when you're building stuff locally. A very wise man, who is my husband, said that 99% of the time, the best way to troubleshoot a test is to rewrite it so it's smaller and faster. Now, Isra does a whole bunch of testing around Android, Flutter, web apps. So a lot of these tests tend to use emulators or end-to-end stuff. So they're long and painful, and just starting up the emulator takes time. And he says that every time he has a test which fails in that environment, he just looks at the test and goes, oh my God, I should have written this as a unit test again. So he finds when you've got a failing, long-running test, best thing to do is break it down into individual component parts and try and write it as a series of unit tests instead. And often, the process of doing that allows you to see what you did wrong anyway. It's a good way of troubleshooting a test. It takes time, but it doesn't take as much time as running a long-running test multiple times throughout the day. Flaky tests, my favorite subject. Flaky tests are dreadful. Flaky tests are tests where you run them once and they fail, and you go, I wonder if it really failed. And you run it again, and it passes. And you're like, well, most people are like, great, it went green, let's move on. Like, wait, but it did fail. Now, is the failing result or the passing result the correct one? You don't know. A flaky test is, in my mind, a failing test because there's something wrong. The fact that you can't figure out what's wrong is part of the problem, really. So the first thing you need to do is identify your flaky tests. At a bunch of conferences like this, I've asked developers, do you have flaky tests? Actually, put your hands up if you think there are one or more flaky tests in your test suite. Oh, good, that's good. Put your hands up if you don't know if you've got flaky tests. Right, and that's kind of a problem. If you don't know you've got flaky tests, that is an issue, because when a test fails, you don't know if it really failed, if it's a flaky test. You don't know if flaky tests are adding extra time and trouble to your build and test process. So the first thing you need to do is identify your flaky tests. DevVelocity has a way of doing this, and what it does is it relies on, I think this might change recently, but it relies on a retry functionality in Maven or Gradle. So both Maven and Gradle allow you to retry failed tests. So if it fails, it'll run it again, and then if it passes, DevVelocity flags that as flaky, because if it passes and fails, then it's inherently flaky. There's another way. This is not a fix. If it fails and you run it again and it passes, that is not a test that passed. That is a flaky test, and you need to do something with that. It doesn't mean that the test, it passes sometimes, it's probably fine. The other thing that you can do is cross-build flaky test detection. This is something that did get added to DevVelocity fairly recently. This is a tool called AutoTrish. Years ago, about 15 years ago, we had flaky tests in our CI environment, and this used to drive me crazy because if a test failed, I didn't know if it really failed or not. So I personally would spend time every morning rerunning every failed test to see if it was flaky or not. And someone who's much smarter than me thought that was a stupid waste of my time and automated this in something called AutoTrish. So it would look at the test pass results over CI over time, and you can kind of see, right, these ones are probably broken, they broke, and these ones, well, they're probably flaky because they pass, fail, pass, fail, pass, fail. So there's different ways that you can do flaky test detection, but do have a look for flaky tests and identify which ones are flaky. Just knowing that you have flaky tests is a good start, but figuring out which ones are the flaky ones is so important, because then we can start attacking them. Ignoring them, right? You know which ones are your flaky tests? Who cares? They're flaky. Doesn't matter. No. It's a really good idea. This is my eldest daughter's favorite movie. It would be a good idea if you could please fix your flaky tests. Because even if you've identified them, and even if you know, OK, this is the flaky one, and I'm not going to spend a lot of time spinning trying to troubleshoot it right now, they are adding complexity to your build. They're adding time to your build if you're rerunning them. They're adding cognitive load of, did I break this or did I not break this? So fix your flaky tests. Dave Farley did a really good presentation, a good video on his YouTube channel about the 5 causes of test intermittency. So I recommend having a look at that. It gives 5 really good pointers for looking at places that could cause tests to sometimes pass and sometimes fail. And some of them are things like infrastructure stuff. Some of them are things like poorly written tests. And some of them are, your production code is broken. Find out what the problem is. So 3, running tests takes time. I really thought that a lot of people would struggle with this. I thought that people would be hating the fact that when they run their build and test cycle, it takes 30 minutes, and they either have to context switch into something else, or they have to wait 30 minutes for the results. But people don't seem too worried about that, so I was a bit worried about this. I was like, maybe running tests doesn't take a long time if you don't run the tests. That's a really good way to speed up tests. And I am a bit concerned that 70.3% of Maven users do use skip tests. I'm hoping what they meant was, sometimes I skip the tests because sometimes I want fast feedback. I hope they didn't mean I never run the tests because, it's really slow to run tests. However, there is a good point. The fastest test to run is one that doesn't need to run at all. So is there a way that we can find out which tests don't need to run? So Gradle has a build cache for both Maven and Gradle. And this allows you to not build modules that you don't need to build, and not build projects that you don't need to build. So a build cache is like any other cache. Given the same inputs, you should be able to get the same output. So if I've built this module before, then I should be able to get the output generated class files or whatever, or test results, without having to redo that whole process all over again. I'm going to walk through a quick example, because let's say you have a multi-module project like this. You've got core in the middle. You've got some dependencies on top of that. Normally, particularly for Maven builds, normally when you make any change and you build it, you have to rebuild everything and retest everything. But with a build cache, you don't have to do that. So if you have only changed the code in the export API, for example, you should only have to recompile the export API, retest the export API. If you change implementation code on the implementation code, yes. No, not implementation code. If you change API code on the service, you only need to recompile the service and rerun the tests just to make sure that everything's kind of fine. You don't even need to recompile the tests if you haven't changed the test code, and so on. The worst possible case is if you change the implementation of something of core, then you're going to need to rerun all your tests across the board. But the idea of using a cache is that you should be able to reuse outputs when nothing has changed. And this is particularly effective for remote build caches, because your continuous integration environment should be running your tests all the time anyway, and compiling your code all the time anyway. So if you get in on a Monday morning and you get the latest changes from Git or whatever, you don't need to recompile those changes or rerun those tests locally, because you can get the results from the remote build cache, because CI already compiled those and ran those. And that saves you a whole bunch of time. Obviously, another way to go faster when running tests is to run tests in parallel. When you're running tests in local, well, so I've got a video for this. So Gradle and Maven, actually, but Gradle allows you to run tests in parallel. I'm really happy that I pre-recorded this demo, because I pre-recorded this last year, and now this doesn't work on my computer anymore. So I don't know why, but I can't compile the Groovy project anymore. But the idea is, you can see that the tests are running in parallel here. You use all of your CPU cores, and you get the most out of your local machine by running stuff in parallel. And Gradle supports this out of the box. So you can get Maven to do it as well. And your mileage may vary, but it's a good way of obviously parallelizing locally. On CI, I expect almost all of us are running stuff in parallel too. We can slice and dice it however we want, whether we run like unit tests separately and system tests, integration tests, or do it by operating system or whatever. We have been slicing and dicing stuff on CI to run stuff in parallel forever. What's an interesting combination of this is to use test distribution to run your tests multi-parallel across the board, even if you are running on your local environment. You can use more agents than CPUs available. So you can have agents available all over in the cloud or on other people's laptops or whatever, and when you run your tests locally, you can massively distribute them if you want across multiple agents. So this then works for CI and local builds and allows you to scale stuff up. Obviously, if your build time is like 5 minutes or no, less than 2 minutes, you don't need to go massively parallel. But if you have a huge build time, like a 2-hour build time, then doing stuff in parallel makes a lot of sense. So Netflix was using Develocity's test distribution. They got their test time from over an hour down to under 5 minutes by going sort of massively parallel with test distribution. And like I said, this works for local builds and CI builds. So it actually allows you to start running stuff locally, where in the past you probably pushed it into CI because it's the only way to go very parallel. But with test distribution, you can run it locally and get fast feedback, get that fast feedback that we want. And so generally, doubling the number of executors cuts the build time in half. That's kind of what you expect. The more agents you have, the faster it runs, up to some sort of point where you get diminishing returns. Let's use AI. So another mention of AI. Develocity has something called predictive test selection, which is an implementation of something Meta talked about in a white paper. So Meta was trying to figure out, they had a huge monorepo, and they were like, look, if I only change these files, why should I have to run all of my tests to make sure that everything works? I really feel like there should be a way to determine that given these changes, I only need to run these individual tests. So what they did is, to begin with, they started looking at like dependency analysis and figuring out like which tests kind of like were impacted by these changes. But they found that generally speaking, every change, one way or another, impacts all the tests. And they were like, well, that can't be right. So then they were using a machine learning algorithm to figure out when these lines of code change, it's generally these tests which will give us the most useful input. Effectively, these tests are most likely to fail if something goes wrong with these lines of code. So then you can train the ML model on your CI environment to say, like, every time these kinds of lines of code changes, it's usually this handful of tests which are useful, provide us the useful input. So that's what we implemented inside DevVelocity. In the white paper, it says, the test selection procedure selects fewer than a third of the tests that would be selected on the basis of build dependencies. So they're saying that generally, using predictive test selection, they found they only run 30% of their tests. So they can ignore 70% of the tests for all the changes they make. We found with our users, so the blue bar, so this is full build and test cycle time. The blue bar is like stuff that isn't testing, so you can ignore that. But the red bar is the amount of time taken running tests, and this is the amount of time that was not spent running tests because predictive test selection didn't select those tests. So normally, testing would take this amount of time, but with predictive test selection, it takes this amount of time. So with our customers, we generally find that often they only run about 60% of their tests. You can move the dials on this because obviously if you want more accuracy, you run more tests. If you want faster tests, you have lower accuracy. So you can kind of tweak those things. But predictive test selection is a good way, particularly locally, of just getting an idea for a sanity check, running just the tests that really matter. And it's very effective. You might not want to run it on all of your branches. Like when you're about to do a release, you probably want to run all your tests. So it's not something you do all the time, but it is something you can do to get fast feedback. Now, if you combine this with test distribution, then you get a really huge acceleration for running your tests. So firstly, predictive test selection selects maybe half of your tests, and then you distribute them over multiple agents, and you can run them in parallel even faster. So you get a really nice way to accelerate tests. Again, probably more helpful for huge mono repos with lots of tests rather than short build and test cycles, but it's very helpful for getting fast feedback. OK. So then I had a comment about, I just have so many tests, so many important tests. They just take a long time to run. Is there something I can do to decrease the number of tests that I have running? And so I asked Twitter again, and Angie Jones, who I love and who knows a little bit about testing, she said, yes, I regularly delete tests that no longer add unique value. It is OK to delete tests. What I found really interesting about the developer mindset, and I include myself in this, is that we don't like deleting things. But it's so cheap to delete stuff, and it's so cheap to get it back again if we find we've made a mistake. It's OK to delete tests. If you've got duplicated tests, or if you've got tests for stuff that nobody cares about anymore, it's OK to delete those things. I don't know anything about gardening, but if you were a gardener, you do prune stuff, you get rid of things, and you take out the dead wood. It's OK to get rid of stuff you don't need anymore. Don't have it just bogging down your code base all the time. So, I asked Twitter, how do you do this? This sounds like a difficult problem, and I feel like it's not something that we have effective tooling on yet. Is there a way to identify your dead tests? And so there's a few different techniques which came up, things like mutation testing to find out which tests are not really doing anything helpful, finding clumps of failing tests, which means there's probably some duplication there. If every time you change this one thing, half a dozen tests fail, then there's probably some duplication there. Certain amounts of code coverage and things. It's a non-trivial thing, I think, to identify dead code. I'm actually going to be presenting on a webinar soon with Azul about looking for zombie code, which I think will be really interesting. That's in the next month. Have a look at my Twitter, but I'm definitely doing something about zombie code at some point, which I think will be really interesting because Azul has a way of identifying dead code that's running in production. But this, I thought, was the most important point here. It says, in my experience, time to run tests and number of tests are not closely correlated. So this idea of I have too many tests doesn't necessarily mean that it takes a long time to run those tests, because you could have 10,000 unit tests, and they'll run in milliseconds, because unit tests are nice and fast. So it's long-running tests that are a problem. You could have a few hundred tests, but if all of them start up an emulator and run through the whole system end-to-end and log in and do this, then that's going to take a long time. So if your tests are slow, you need to do some analysis on why they're slow. And it's like any other performance problem. Find out which are the worst performers, which tests take the longest time, because maybe that's one that you can delete, Or maybe that's one you really need to break down into individual unit tests, or maybe analyze exactly what's going on. Are they doing a lot of stuff in setup and teardown? Are they doing a lot of things in every individual method, which could perhaps be reused somewhere else? So my thing is that I think you really want to be pushing stuff down that testing pyramid, away from the long-running, more integrated tests, and down towards unit tests. Now, there's a lot of arguments over what a unit test is. A unit test can be a sociable unit test, which uses multiple classes together. It doesn't have to be one class, one test. Sociable unit tests are still nice and fast. They don't have databases. They don't have a UI. They don't have a lot of other slow stuff. Kelsey Hightower said, once things like databases become a hindrance, optimize the testing loop, mock things out to run things fast. You can run locally and don't have all the same infra dependencies as someone else. So this was part of a podcast I was listening to. It's tempting at the beginning when we're writing the code to start with it to do end-to-end and integration tests, because we can reason around the user does this, they go here, it does this, it goes in the database, it comes back out the database the shape that I want. As time goes on, writing more and more tests like that is infeasible. So you need to start then refactoring your tests to take away some of those dependencies and see if we can move some of that stuff into unit tests instead of integration tests. I've got 3 minutes left, and I think I've got a lot of slides. So you need to look out for expensive setup and teardown. If you're initializing a database connection in every setup, that's going to start taking time. So look for things like setup and teardown. Look for things which are being done time and again, and figure out if that's the sort of thing you really need to be doing or not. Invent time travel. When I worked at LMAX, we actually had time travel tests, because we needed to test things like what happens at end of close of day, what happens when the day rolls over, what happens at the end of the month. And what we didn't want to do is create an automated acceptance test which kind of waits until 5 p.m. and then checks the status at 5 p.m. That's infeasible. So we created a system whereby instead of using the system clock, we had a clock service which would tell all the other services what time it is, which is kind of nice anyway. But for testing purposes, you just stub that out with something else, and you tell the clock service, it's 5 p.m., do the thing that you need to do. And so it was a good way of really speeding up our tests. We didn't have to wait for the end of the hour or the end of the day. You can just tell it what time it is. And respect your test code as if it were production code. I know, this is like a crazy idea. Why don't we treat test code like production code? Why don't we respect it? Why don't we make sure we have separation of concerns, encapsulation, solids, scripted naming, and all those things that we do in our production code? Why don't we do those for our test code? It makes our test code easier to read, easier to reason about when we're trying to troubleshoot it. It often makes it faster if we have better design. So we need to think of it as a first-class citizen, not some kind of add-on, oh, and testing, we should do that. There's tension between those different ideals. These things are, oh no, what have I done? These things sometimes are in contention with each other. They sometimes, like, for example, separation of concerns in testing is a good thing, but it also means that perhaps we end up duplicating a lot of work, and maybe we end up having a lot of stuff in setup and teardown when we actually want to speed some of that stuff up. But the tension between these ideals, that's what technical design is all about, making those trade-offs and deciding which trade-offs we want to make this time. Dave Farley has a good book about that in Modern Software Engineering. I'm talking about Dave a lot, but like Dave's stuff really impacted how I think about this. In summary, of course you want to automate as much as possible. I'm talking about automated acceptance testing, but acceptance testing. And so use your IDE, use AI tools if necessary, use things like any tooling that you can use to speed up writing and reading code. And there are solutions out there designed for exactly this problem. So we have got ways of creating new code. We have got ways of analyzing the problems, but also for running code. The fact that you can run tests in parallel, the fact that you can use machine learning techniques to decide which tests to run, these solutions do exist. They are out there. There is a time investment in writing tests because there should be thinking involved. So testing will always take a certain amount of time, because you should be thinking about, is this the correct behavior? What should it do? What should it do when the user does something stupid? Because they will always do something stupid. What should it do if the database goes away or the network just freaks out? We should be thinking about these things. Now, if you think about it during writing tests, you have to think about it either when you're writing the production code or when you're writing the test code. It doesn't really matter when the thinking happens. The thinking has to happen at some point. So it will take time. And the final thought I want to leave you with is your best and wisest refuge from all your troubles is in your science. So there are engineering solutions to these problems. There's tools that can help us, and there's process of iterating over some of these things and refactoring our tests towards something better. This is an engineering problem, not some sort of like hand-wavy art. Right, oh my God, I finished with 3 seconds to spare. That was amazing. If you want to know more about this topic, this is the link to a page on my website which has like 1,000 links on all the stuff that I talked about, the predictive test selection paper, all sorts of bits and pieces. If you're interested in winning my Getting to Know IntelliJ idea book, follow this link and put in your email address, and hopefully you'll be lucky. I'll do a prize draw and let you know. It's going to be a virtual copy of the book, so you'll get it in your email. Thank you very much.